Immutable Destiny yet, so if he wants to take...
Yeah, well, go ahead. I'll just mute and stay here.
No, I was just going to ask him if he wants to take a minute and explain his position and where he's coming from, and if he has a channel that people should look for. I don't know, just a little something. I can do the same, and we can go point by point from there.
Sure. I accept evolutionary theory mainly because I've been taking courses that pertain to evolution, like genetics and things like that. I know friends, we talk about it. I was convinced that it's true. Yeah, I pretty much just on the internet to talk to people, meet new people, share opinions, things like that. Nothing special. I don't really have a channel that's dedicated to creating content as much to just go on air and chat.
Awesome. Okay, yeah. So obviously you've taken some courses. You hold to evolutionary theory, universal common descent, and then obviously I hold to more of a biblical creation model. I just find it so interesting looking at, say, the empirical data, looking at all the obviously observable evidence, and especially in regards to living organisms. I think a lot of the debate comes down to a genetic level, right? Because obviously traits, those are what's inherited, right? Fossils, bones, these things aren't inherited. So I think if we're looking at, say, limits versus possibly, no limits, or a gain in new novel information versus, say, a loss in information, because I think I would hold to the position that God created, pre-existing heterozygosity. So a lot of the, nuclear DNA differences that we see, say, among species, within species, I'd say that a lot of those were encoded, say, into the original creation. Because if you think about it, like a single human couple, if they contain designed and functional heterozygosity, say even in a tiny fraction of their nucleotides, they would be able to produce, say, with recombination, segregation, things like this, an essentially unlimited range of useful diversity. So I think based on that pre-existing heterozygosity, we'd see change, we'd see speciation, but I'd say it's more so based on a sorting of information, and maybe a decompression of, say, compressed and hidden information. And I would predict that there'd be limits. So I think going into our discussion, I asked CRISPR this too, and I'm sure you've been asked the question too, but maybe just to kind of understand, I guess, your position a little better. Like, do you believe, because obviously if you look at, say, dogs, mice, we'd agree they're both mammals. So would you say that, you could get a dog as small as a mouse, or even an elephant, right? That's a mammal as well. Do you believe we can get a dog as big as an elephant? Because we know there's animals as big as mice and elephant, like mice and elephants. Like, how do you feel about that? Are there genomic limits, physical limits? Go ahead.
I mean, I think if you're talking about a particular animal, there's, we see different kinds of animals, and we see that they have different expression of traits.
Check the side, Immutable.
Huh?
Check the side.
Yeah, I know. I've taken genetics, I know. But anyway, back to the question he was asking. I think there's some limits when you start talking about, like, if you're talking about, like, embryonic development and kind of the proper size for an organism to be. You do see relatively small species like chihuahuas and things like that. But
well, do you believe that you can get a dog? So obviously I understand that, because I'm not arguing that obviously, domestic dogs, wolves, coyotes, foxes, dingoes, I would say that they all descend from a single common ancestor. But like, when it comes to the change and the limits within the change that we see, like, do you believe we can get a dog as small as a mouse? Because we know they're both mammals. We know animals exist that are as small as a mouse, like a mouse. So do you believe that would be possible given, say, enough time, enough change, enough processes? Go ahead.
Well, I mean, I think part of what defines a dog is characteristics we ascribe to it. So asking, can we get a dog as small as a mouse is kind of in its own right a nonsensical question, because what you're asking in essence is, can a dog have such a level of similarity as a mouse does? Well, I mean, to some extent, if you're comparing it genetically, but on a physiological level, not really.
Well, like, do you believe that dogs, mice, and say elephants are related through common ancestry? Like, if you go back far enough in time, are you gonna be able to trace back that common ancestry, whether it's within a phylogenetic chart or go ahead?
Yeah, you would. And I'm not a
Okay.
phylogeneticist, so I would
And, and,
imagine
and
probably.
that's because I would say that I can't exactly tell you where that barrier is or where that limit is, but I would say no. You're not going to get a dog say as small as a mouse or as big as an elephant, right? Because I would say there's limits based on that.
Sure. But I mean, I think if you're sure, I would agree to that much. But I think if you're going more in terms of like retro, if you're retro and if you kind of trace back thinking, right, there comes a point in time where dogs begin not to be what we would consider dogs. There's something else. They come from a more primitive species, and these primitive species come from even more primitive species.
Okay, so for example, like I understand the law of monophyly, like we never outgrow our ancestry, right? So say the origin of, eukaryotes from prokaryotes, a eukaryote will always be a eukaryote, and then, a mammal will always be a mammal. Like, we're never going to outgrow our ancestry, right? So I understand the law of monophyly, but would you say that, like, say a population of non-dogs today came from something that was non-dog long ago and far away? And do you believe that a population of dogs today, given enough time in the future, could become something non-dog? Go ahead.
Well, to answer your first question, yes, a population of non-dogs did become a population of, eventually gave birth to successive populations of what we do consider now dogs. The evolution of Canis lupus to Canis lupus familiaris.
Now, if we, and I understand the law of monophyly, obviously, if we see, say, dogs producing a variety of dogs today based on, the genetic code, I would say that there's obviously limited information within that dog gene pool. Is it scientific, empirically, to say that dogs today, given enough time, that they came from something that was non-dog long ago and far away? Like, is that empirical science in your opinion?
Yeah, I would say it is, because I would say that, now granted, I'm not a geneticist, so I don't have access to data that, of Arctic wolves that existed what we consider to be hundreds of thousands of years ago. But from, from what I've heard from my talks with people, they would say, yeah, look, you can find a fossil in the ground, run PCR on it, get data from it, and compare the genome sequences, and you can see quite readily that the DNA sequences of these two things are related. And that particularly, there's genes that are changed and related to more social behavior within dogs, or less social behavior in dogs, which is not present in wolves.
Okay, so obviously, if we look at, like, let's take every single dog on the earth today. Let's throw them into, say, Alaska. Okay, over time, obviously, I believe natural selection is a fine-tuning selection process. Natural selection is going to select that trait, say, for long, thick hair, thick fur. Over time, all your dogs are mostly going to die except for, say, your huskies, right? All you're going to be left is probably with a population of huskies, right? Take those huskies, throw them into, say, the desert of Australia. Natural selection is going to select out that trait, say, for short, thin fur, skinny legs, something like a dingo. Then all you're left with is a population of dingoes. So natural selection is selecting from that pre-existing information, but all you're going to get are a variety of dogs. Go ahead.
Actually, but stop there for a moment, right? Are you familiar with the saying that the genes are plastic to the environment?
I think I understand. Can you explain it?
So, with genes, saying that genes are plastic to the environment, it refers to the fact that genes, fundamentally, what they do is they code for proteins, and these proteins are used by the body in places that they're needed. But fundamentally, what it means is that when genes are expressed by an organism, right? Like let's say it's in the Arctic Circle, or in the Sahara or someplace like that. The function of that gene is influenced by the environment that organism is present. So, the difference between the Sahara and the Arctic Circle, right? Some organisms, due to the temperature or due to the pH or due to certain lack of resources, may express those genes at a particular rate. And the proteins that are produced by these genes may only be used in a specific way.
Okay, so are these genes pre-existing genes, and now there's, say, new traits, new proteins arising from, say, an amplification of that pre-existing information? Like, is this process that you're talking about, is this going to take a non-dog into something that's dog, given enough time, given enough processes change? Because in my opinion, and I think it's pretty evident that mutations, they're not construction, they're destruction, right? We see a significant loss of information in regards to, say, mutations. So how are you going to get?
Well, I would disagree with you on that point if you were going to argue that mutations can only cause damage to a genome, or that mutations are only deleterious to the genome.
But like, if you look at a poodle, okay, so a wolf to a poodle, that's the degradation of a genome, right? That's like, going from something that's got significant heterozygotic, DNA sites to something that has, more so homozygotic DNA sites. Like, that poodle has lost so much information and so much allelic potential. I don't think you're going to take two poodles and artificially breed them back into a wolf, because that degradation and that sorting out process has already happened. So you get a dog degrading into a dog. But
okay, but also consider, right, that particular organisms, let's say for arguendo's sake, I don't know this, I'm not claiming it, but let's suppose, for instance, that dogs and wolves share the same genes, right?
Sure,
So,
yeah.
like,
I agree they do, right? I'm sure you can find those nuclear DNA differences, those mitochondrial DNA. I'm sure you see plenty of similarities.
And my point, though, is that, like, particularly the difference between dogs and wolves, their primary classification, like the main reason we create the distinction between dog and wolf, not only because of their evolutionary history, is because of their social behavior. Wolves are more of a pack species as opposed to dogs, which operate more or less independently. Plus, I mean, it is likely to be the case that because wolves are non-domesticated, that they require the use of certain genes to be expressed more often, whereas opposed to a dog does not require the same genes to be expressed at such a high level.
Okay, so and I understand what you're saying, and I understand the outcome and results of these changes. But like, for creationists, so for myself, like I said at the beginning, heterozygosity, which just really means just millions of, say, differences in DNA sequences and obviously chromosome pairs, right? We've got 46 chromosomes, more than enough information packed and compressed in those chromosome pairs to provide the necessary variety. So I would say that heterozygosity was built into organisms, say, from the beginning, right, by the creator. That means long periods, because you're talking a lot about 100,000 years, 100 million years. They're not really required for, say, the production of new species. And here's what's important, because if I start with heterozygous organisms, visible distinctiveness, immutable, it's in offspring, it's going to be apparent. Okay, so recombination, gene conversion, things like this, that's going to provide many new varieties of combinations of traits quickly, since these differences are already built in. So my point is, these changes, these traits you're seeing, if they're being emphasized by, say, the pre-existing information, I don't believe you're going to get a dog as small as a mouse, and I don't believe that you're going to get a non-dog into something that's a dog. And it kind of seems like you're admitting that there are limits. So I just want to see where that empirical evidence really is. Go ahead.
No, so I'm kind of curious as to what you view particularly as information, because from the standpoint of genetics, it comes down to DNA and how it's read by RNA and tRNAs that deliver amino acids, right? So, I mean, I'm not sure how familiar you are with genetics, but
I would say that, like, obviously a definition of information, it's not easy to come by. I would define it as more of like an encoded, symbolically represented message, but it's going to be conveying expected action and intended purpose. Like, for example, if we look at the English language, let me just make this easy through analogy, ask you a question and let you answer. It's made up of 26 letters. Let's take an English book. Okay, it's made up of words, chapters, sentences, paragraphs. Those are made up of that specified information, 26 letters. How long is it going to take through, say, typographical errors and misspellings to turn that English book into something that's not an English book, say something German, Korean, because it's a different code, right? So how long would that take, and is it possible? Go ahead.
Sure, I don't know. Quite honestly, the answer is irrelevant because it's entirely disanalogous to the way genetics actually operates.
I would disagree that I think the fact that you say you don't know is probably analogous to the fact that a non-dog population is not going to become, because you can believe, obviously, through faith, that a dog today came from something that was non-dog. But if we see dogs producing more dogs and we admit there are limits, you're not going to get a dog as small as a mouse. At the end of the day, we're just discussing religions, because I would say, and no offense, that what you have here is a deeply held science fiction based religion, right? Because if you can't explain to me
exactly how that's religious at all, the entire claim of evolution, and no more no less, is that change in allele frequencies, which you agree with, over successive generations, which are heritable by their offspring.
Well, we can see that these traits are heritable. I understand, like fossils and bones, those are not inherited. So if we're looking at a genetic level, because I'm telling you that heterozygotic DNA, it is logical, coming from a creationist, because God's command was to be fruitful and multiply. So he's obviously not going to create clones. And since he could not have done that, it's obvious that he would create heterozygous DNA. So when you say that these traits are coming about through different environmental and selection pressures, that's expected, given our model of pre-existing heterozygotic DNA. Go ahead.
Well, great. Then you don't have an argument, because that's what evolution predicts.
But how are you?
That the change in allele frequencies over populations given successive generations causes speciation.
Yeah, so obviously anybody could, because I agree, evolution means a change in gene frequency, a change in gene pool, a change in allele frequency in populations over time, right? Not individuals are evolving, populations are evolving. So no one's disagreeing with that. But the question is, are there limits? And I believe there are. You're not going to get a dog as small as a mouse. And we know there's animals as small as a mouse, like a mouse. And you seem to agree. You're saying that dogs today came from something that was non-dog, long ago and far away, and that's fine. You can have that belief, but it's my point and my contention that that's not empirical observational science, because we observe limits. Look at Lenski's experiment. How many generations of E. coli has he produced?
Well, before I answer that question,
more E. coli.
Well, before I answer that question, right, I'm curious as to what evolutionary biologist has tried to make the point that you will get a dog as small as a mouse. And I've listened to quite a few of them, and I don't think I've heard that one particularly. I mean, granted, maybe it's a Freudian slip, but I don't think I've heard that one.
Well, and I'll answer that too, but what do you think about the quote, and you can look it up because I don't believe it's a quote mine, by Dr. Michael Roos. He's an atheist zoologist and philosopher, right? So what he said, and he's obviously has an evolutionary bias, and he's even admitting this. He's saying that evolution is a religion. This was true of evolution in the beginning, and it is true of evolution still today. And I could provide that source. Would you agree with Dr. Michael Roos on that idea?
No, I wouldn't, because I would disagree in how he is characterizing a religion.
Well, because if we see dogs producing dogs, mice producing mice, elephants producing elephants, but you're saying that mice, dogs, and elephants are all related through common ancestry, and yet we see clear limits today in the present. How is that not a religion? Because that requires faith. And
okay, so the question of how is it not a religion is like if you're saying that because we can't see it, so let me say it this way, right? If the strict reason you reject it is because you can't see it for yourself, and that's grounds to reject it, that's an argument from ignorance. But the better answer that we have, right? So the better answer that we have is by going back to the fossil record, is by going back to the history of organisms that have existed.
Okay, and I'll let you continue, but I just want to say, you know, we find bones in the dirt. There is no fossil record. You know, we find bones. It doesn't come with a label on it. It doesn't come with an identification card that says, hey, this evolved into this. This is the ancestor of this. And why would we expect a bone found in the dirt to be able to do something that an animal today can't, which is add new, novel, and meaningful information to the genome? Because my point is, empirically and observationally, we see limits. So that's why I'm saying everything you're telling me is contrary and contradictory to presently known data. Go ahead.
Well, okay. What you just said disagrees with what we said earlier, because even when we were talking not 5 minutes ago, me and you both had the point that if I have an organism which is in two different environments, which under environmental pressure, right, the DNA may not be mutated at all, but the same gene, the same product that's produced may serve different functions in that particular case, which is generating novel information, so information, at least from a biochemical standpoint, would be how some kind of structure behaves in the organism that it's found in.
Okay, so far, and I get what you're saying. So far we've agreed that there are limits. We're not going to get a dog as small as a mouse, even though they're both mammals, and apparently, I guess they're related through common ancestry. I think you believe that. At the same time, we see a degradation of genetic information. We see a lot of these new traits and a lot of these new, say, varieties based on pre-existing information. What would what mechanism is going to add, say, new genes, new novel information? Like what's going to overcome that degradation found in mutations? Go ahead.
Well, sure. So I mean, what could cause new information? You could have polyploidic organisms, you can have viral infections, you can have organisms like viruses, for example, that insert their own DNA into the DNA of its host, which for some reason, which may unexpectedly create or extend some kind of new protein, causing it to have some kind of new function.
Okay, so let's take these, obviously bit by bit. We don't want to, name 10 and only be able to talk about 2. So these polyploidy organisms, would that be, say, based on gene duplication? Is that like duplicating of the existing information? Is that what you're saying?
Well, it could be gene duplication, but it could also be duplication of an entire chromosome.
Okay, no, and I understand. So if I give you a copy of a book that you already own, okay, and say I start putting typographical errors and misspellings in that second copy of the book you already own, now all you have is a messed up copy of the original book. You have nothing new and meaningful. And as a matter of fact, gene duplication leads to many diseases and disorders. Like I believe Down syndrome is based on a duplication of a certain gene. So once again, mutations are not construction, they're destruction. So I don't see how that's going to take your fish to fishermen.
So the point is that although the vast majority of mutations appear to be damaging to an organism, there are a few cases like the duplication of PLP genes, which produce venom in snakes, is an example of a beneficial mutation for at least that particular variety of snake.
Okay, so
let me use my own analogy for a moment, right?
Yeah.
Let's say I have cousins, I have little, I have children, well, not children, but friends of mine have children, occasionally look after them, and playing with Lego blocks, right? A single Lego block on its own can't do much, but combinations of those Lego blocks, various combinations that they can assume, and combining them can create novel structures. And
okay, so
once again,
yes, but do we observe this in real time? Because if we actually look at these gene duplications that you're talking about, and I think we might be able to agree to this, because I think you just said that the overwhelming amount of mutations are deleterious, but it's not really a common event, right? So even 0.01, say, duplications per gene per million years, say for example, macroevolution, your pond scum to people type evolution, it needs a lot more than, you know, the 0.01, because the massive amounts of living things we see today, and we do see a lot of living things, the numbers just don't add up, even with their millions or billions of years. Go ahead.
So here's kind of the crucial crux of the argument, right? Is that so that evolution, as we agreed earlier, doesn't occur within individual organisms. It occurs within populations. So an analogy I can use for this case is that, let's say me and you are playing a game of dice, and we have 2 dice in front of us, and you ask, hey, what's the probability that I'm going to roll 2 6s on the same roll of a die? Okay, well, that corresponds to some probability. Now, take the same situation, but instead of 2 dice, I have 2 million. And I ask the same question. Well, what's the likelihood that I'm going to roll 2 dice that have a 6? Well, the odds increase exponentially, because especially when you're dealing with organisms that reproduce quite quickly.
Okay, so like, are we shuffling, you know, the pre-existing, like, is this, could this be considered recombination? Like, are we shuffling pre-existing genes, and this is what you're saying are going to lead to new traits, new structures overall, right? Change in allele frequency over time. That's what's going to take your bacterial biology.
Hold on, before you do that. So what's going to add information to the genome, which is the question you initially asked me, is the fact that individual organisms may not produce a beneficial mutation, but populations, because they're extremely large, because mutations happen on a day-to-day basis, a single mutation that is considered beneficial to that organism will pass on to its generation easier than mutations that are detrimental to a population.
Okay, but if you look at a beneficial mutation, you know, I believe there are beneficial outcomes. I mean, there's a mutation on wingless beetles. Okay, so they had a mutation that resulted in the loss of wings. Okay, but the thing is, the island they were living on was windy, so that it was actually a selective advantage. It was a beneficial outcome because now they can survive better. But at the end of the day, they lost the information for wings, right? So it was a degraded advantage, and the majority of examples, say, of beneficial mutations that you're talking about, they are deleterious, and they are the result of a loss of information. That's still not going to take your bacterial biologist. Go ahead.
But hold on, before you respond, it has been brought to my attention that that the quote from Michael Rose or whatever the heck was a quote mine. I will read you the exact quote that someone sent me. Hang on a sec. It's from the book "Is Evolution a Secular Religion?" And the quote is: "If the claim is that all contemporary evolutionism is merely an excuse to promote moral and societal norms, this is simply false. Today's professional evolutionism is no more a secular religion than industrial chemistry." So I don't know what look. I'm not saying you didn't intentionally.
I don't even see that quote that I said in the paragraph you just said. Like, for example, evolutionists will.
But here's the thing. You claimed that Michael Ruse said that evolution was a religion, and I read you the quote where where he doesn't say that.
I read you the quote where he did say that, and now you're reading me a separate quote from some.
Okay,
for example, evolutionists will accuse. Well, just wait. Evolutionists will accuse us of quote mining Darwin because we'll provide the quote of how he talks about how difficult it is to explain the evolution of an eye, and we end it there. But if you continue reading, he explains a possible scenario of how the evolution of an eye can happen and occur. That would be a quote mine because we're not showing you the rest of the quote, but you're showing me a quote from something completely separate of the quote that this was taken from. So that's not really a quote mine.
Hold on, is the quote that you said from the book "Is Evolution a Secular Religion"? Where is the quote from? What is the full quote? Can you show me the full quote that the quote that I've shown isn't a quote mine from? I know it's a four-phrased question because of the way I speak, but it's a separate quote
from a separate book. I can find the exact quote, the location of the quote for you, if you'd like, and I will provide it. But it's not really the same type of accusation as if, you know, we're negating, you know, the next paragraph of a quote that we've.
Okay, so Crispr, go ahead. Crispr, Immutable, we'll get back to you soonish. Sorry, go ahead, and Crispr.
Actually, Immutable. Okay, go ahead. Yeah, go ahead.
Can you show us not where Roos said it, but can you show us where you found the quote? Because I'm assuming you didn't read through all of Roos's work. You saw that quote somewhere, right? And now you're showing it to us. So where did you originally see it?
Is this Crispr that's talking?
Yeah.
Oh, I forgot. I'm pretty sure this is a discussion between Immutable Destiny and I. So like I said, here's the quote. Okay, so it is, let's see here. Is this the one that you provided, Athena, where he says evolution is promoted by its practitioners? Okay, so here's the full quote. Evolution is promoted by its practitioners as more than mere science. Evolution is promulgated as an ideology, a secular religion, a full-fledged alternative to Christianity with meaning and morality. I am an ardent and evolutionist and an ex-Christian, but I must admit that in this one complaint, and Mr. Gish is but one of many to make it, the literalists are absolutely right. Evolution is a religion. This was true of evolution in the beginning, and it is true of evolution today. This is the exact quote. There's no quote mining. I mean,
okay, but where's the source? That's what we're asking. Where, like, is it from a book? Is it from a website? Where's the, like, you know? Okay, yeah. I just want to know where the quote is from, and then afterwards we can give it, you and Immutable can get back to it, because you know what I mean.
Yeah, I'm currently looking for it. Don't worry. It's there. It's either in a separate book or separate paper. You know, try not to lose any sleep over this, guys. But as I'm looking for it, I wanted to ask Immutable Destiny this, because I like his analogy about the Lego blocks. And Immutable Destiny, like, have you played? I'm sure you've played a card game, right? A common deck of 52 cards, right? It includes 4 groups. Okay, so hearts, diamonds, clubs, and spades, for example.
But now, anyways, you know what? Just get back to talking to Immutable. It was just something that was bothering me, and you know, the whole quote money thing. It just, go ahead. Whatever. Okay, sorry, I distracted.
That's okay. That's okay, brother. We're still friends now. This common deck of 52 cards. Okay, hearts, diamonds, clubs, and spades. They're each. I'm trying to gather my thoughts here. So they're each going to have 13 different numbers or faces. Okay, 2 to 10. You know, Jack, Queen, King, Ace. Let's say we're playing a game bridge. Now, each of the 4 players, say they get a hand of 13 cards, okay? You can play bridge for 50 years. And some people do, believe it or not, without ever getting the same group of 13 cards. So the hands you were dealt, they are constantly changing, like you were saying earlier, and each is unique. But the thing that's important is the deck of cards, they remain the same always. And that's what I'm trying to say, that we see variation based on that pre-existing heterozygosity.
Of course, but the issue is
dogs and cats remain cats. Go ahead.
So the issue is the same one you had with the earlier analogy, and that is that the nature of the genetic code, right, via gene duplication, via polymorphism, via viral infection, can add to the genome, or in certain cases can cause expression of certain genes that are already existing to create more of itself. So this analogy of 52 cards is fine, except for the genetic code operates in a completely different way.
And I want to comment on that, but what I want to do real quick is just post up. That quote came from an article. You can find it on www.huffingtonpost.com/Michael Roos /is Darwinism a religion.
So you didn't read the actual book. You just read an art. Okay. So they are the ones who took him out of context.
If I may,
it's not out of context, because you can read the entire book. article, and you can go read the entire book that quote was from, but it's not quote mining because that quote came from that article. So I'm not sure the book
Yeah,
came.
but my question would be: is the quote genuine to the book? Like, did it come from? You know what? Never mind. Just talk to Immutable.
Okay, Immutable. So are you saying that gene duplication? Like, let me ask you a question. Okay, I'm gonna ask you two separate questions. Can gene duplication add new, novel, and meaningful information to the genome? Yes or no?
Yes.
Okay, second question. Can gene duplication add new, novel, and meaningful information to the genome?
Yes, that's the same question.
Exactly. So you can duplicate the pre-existing information all you want, but you're not getting anything meaningful. Increasing
Well,
the
okay,
information
once again,
content
right?
is not the same thing. Go ahead.
So the issue, once again, is that when you're trying to use the example of linguistics, we agree we agree upon when we're talking that certain words have certain meanings and that these meanings are contingent upon the context we're using them in. So of course the meaning won't change. The issue with genetics is that it is constantly changing. You constantly have things that are trying to transcribe different genes. You have certain things that, like methylation and acetylation to nucleosomes, that are repressing the rate at which genes are activated and transcribed. You have molecules that inhibit or molecules that sometimes try and activate certain proteins to produce more product.
Okay, but
So
if
you always
both,
have situations in which the genome, in which the organism itself is behaving as a dynamic system.
okay, but if most, say, adaptation is due to fine tune, like, would you agree that natural selection is like a fine tuning process or like a selection process? Would you say?
I would say that. Okay, so to answer your question, because I'm not entirely sure how to unearth that question necessarily, but I'll answer the question this way. I would say that natural selection is a process by which organisms that obtain beneficial mutations via mutation or some other means
Okay,
are
can you
selected
give me
over. Can I
Okay.
finish?
And I just want to stop it when you said beneficial, because I gave an example of a beneficial mutation, but it was clearly due to a loss of information. So I want to know if there's any truly beneficial mutations that are not ultimately deleterious, and that actually, increase, say, the genetic information and make it better overall. And then,
Okay, so before I answer that question, right? What
Yeah.
specifically do you mean by deleterious? By deleterious, do you mean that it alters the function of the original gene, or that it actually deletes information within the existing genome?
do you want to talk about like a specific mutation in regards to that, like a point mutation, inversion, insertion, frame shift, something like that, or do you just want like a basic?
I just want a basic
description of-
definition. Like, so for instance, right?
I think it's pretty simple. I just gave an example of a population of winged beetles that lost their wings. They lost their information for wings. Now they have a selective advantage, but it's based on a degenerated adaptation. That's pretty clear
Right.
that that's ultimately deleterious. Go ahead.
Right. So once again, that triggers the same question. So is that particular phenomenon based upon the inactivation of that gene? Is that due to something within the genetic code that has changed?
Exactly. Like I said,
something-
God created pre-existing heterozygosity, created pre-existing design variations. So if we're seeing these new traits arising based on pre-existing information, that's more consistent with biblical creation and more inconsistent with fish to fisherman evolution. And that's the whole topic. What kind of change do we see? Do we see limits? Do we see adaptations and variations based on a loss of information? Because that's more consistent with both genetic entropy, second law of thermodynamics, and biblical creation. I mean, that's what we predict. Everything we see is so consistent. It's actually amazing. Go ahead.
Well, okay, entropy doesn't really apply here, and I'll
I'm
ask you
talking about entropy on a biological level, right? The accumulation of individual mutations.
It still doesn't apply.
How come? What's your definition of the word entropy?
Okay. Okay. First of all, before I answer that question, are you familiar with what entropy refers to and how it refers to the system?
So, are we going to look at, say, the second law of thermodynamics, that energy increases as matter or energy becomes less usable, right? Like the energy available, say, for useful work in a functioning system does tend to decrease, even though the total energy remains constant. So really, in
Sure.
general, the second law of thermodynamics predicts that a system left to itself will, in the course of time, go toward greater disorder. I mean, have you ever seen your hair in the morning? That's entropy right there.
Except for there's another issue that you're forgetting to mention, right? And that is the fact that entropy only applies to closed systems.
No.
I'm talking not a closed system.
The word entropy is I love when evolutionists say this. The word entropy, like, it's just like the word evolution. It can mean and apply to different things. Hey, the evolution of languages. It doesn't mean that, language is evolving in the biological sense. When I'm talking about biological evolution, I'm talking about the accumulation of near neutral and deleterious mutations. Much like rust on a car degrades a car, much like these mutations degrade a genome. That's all I mean by entropy. So it's a straw man to say that I'm trying to imply that the second law has to do with that. Go ahead.
What you seem to be implying is that there is a loss of information because the amount of genetic information within an organism is fixed throughout its existence, which, as I've demonstrated, isn't necessarily the case. People get viral infections. Some people occasionally have gene duplication. Some people have even, Turner syndrome, Down syndrome, cases in which the polyploidy of an organism is changed.
Okay, so we talked about polyploidy, we talked about gene duplication. Are you talking about these viruses? Are you talking about the endogenous retroviruses, like that inserted genetic material, AK and ERV, into, say, ape ancestors or other, or is that what you're saying is the addition of information, or am I mistaken?
Any viral infection can cause an addition to information, right?
Okay, if we look at, say, we'll just use endogenous retroviruses for example. If they're found to have function, wouldn't that indicate that it was highly unlikely that they were inserted by retroviruses? And here's the important part: functional endogenous retroviruses, say an endogenous retrovirus that plays a role in, say, the placenta or the embryo, that would actually depend very heavily, and we might be able to agree on this, on their position and their sequence. That means if they were positional and positioned slightly wrong, or they had the wrong sequence, they wouldn't be functional. But the fact that we see function would point to design rather than, say, a genetic marker that proves common ancestry. Go ahead.
Well, okay. So the first issue with that necessarily is that you're starting from the top, taking a top-bottom approach. Whereas, let's say I get infected with some virus, right? And that particularly this virus is beneficial and it gets passed down. It's more likely to be the case that the virus, as it travels through the body and replicates, or the body as it continues on through its cycle, if it is indeed beneficial, will find a place where this virus is useful and will engage in sites that are symbiotic towards both the organism and the virus.
Yeah, but it's position. Like I said, if they were positional and positioned slightly wrong, or even the wrong sequence, they wouldn't be functional. So the fact that, what you're saying, I see that more as a rescue device, because you've seen that these ERVs are now functional, and now you're much like the non-protein coding regions we find that are actually, transcribed, say, into RNA and revealing, say, functions and the trajectories looking towards function. I feel like that's the evolutionists trying to come up with an explanation, because that seems like
what we're doing fundamentally. What we're doing fundamentally is explaining different explanations that we have. You're saying that I'm coming up with an excuse. I'm saying that based upon selective pressures like pH, based upon where particular resources that a virus may have that an organism may not have on its own, can dictate where a virus may be likely to be found in an organism as opposed to where it's not.
Well, okay. Would you agree, though, that these endogenous retroviruses do have functional roles, say, in the placenta and in the embryo? Like, would you agree with that?
Sure. Before I respond to that, CRISPR seems itching to get in, so I'll let him join in for a moment.
No, wait, I've already had a conversation with CRISPR for an hour last time, and with Athena for an hour. I'm having a good conversation with you. Once we reach the hour mark, I'll go into a discussion with CRISPR. How long have we been talking? Athena, can you give us a minute count there?
Let's see. Okay, what time did you come in? I think you have been well, okay, you have been talking with Immutable, but there was a little interruption. So you know what? Talk to Crispr for a bit. I think it's been I think it's been
Well,
just 16
okay,
minutes.
well, just a little bit more with Immutable, because I want to see what he thinks about this, because you know, would you agree that some in the past did say that our non-protein coding regions, they were, say, inactive, redundant, or even left over from an evolutionary process? Like, would you say that that's accurate?
I'm not sure. I'm not really well read on the literature, so I'm not going to comment on that one.
Okay, but
I've heard both positions announced before. I've heard people that say, "Hey, look, people in the past thought that this may have been functional, but couldn't prove it yet." But I've also heard people say the opposite, like what you just said. So
okay,
the thing is that I don't have enough background information personally to answer that question.
do you know how scientists perform experiments to determine the function of DNA? Like, if we look at a mouse or a non-human species, do you know how that they would definitively determine a function?
Modern day, you would use usually knockout experiments, so knock out
Yep.
a gene and see how an organism responds to it, or try and create point mutations within a particular type of protein.
Exactly. So yeah,
Things like that.
yeah, like, in other words, so like, just like you said, sections of DNA are removed, say, from the genome of an organism, and then we look at what the effect, this removal is going to have, right? So in this way, like you said, we both agree functions of sections of DNA, they're going to be determined. Well, what's most important about this, and I'm glad that we agree with this, is comprehensive knockout experiments for a mammal. That is actually have yet to be performed. So they would actually be premature. Like, when I was talking to CRISPR, he seems to believe that he understands, so much more about the genome than 99% of scientists, which is pretty cool. I got to talk to this CRISPR guy a little more. So I would say it's premature to make the claim that the majority of non-coding DNA is non-functional. Okay, because comprehensive knockout experiments haven't been performed, so you can't say that for certain. And if the ENCODE project did examine 1% of the non-coding DNA of the human genome for possible function, and what they found was at least 80% of the non-coding DNA was transcribed into RNA, that does suggest function, and that is consistent with biblical creation. Go ahead.
So, first of all, if I recall right, I'm not sure how many they've done, but I know there have been a few experiments that have dealt with knockout experiments on certain genes in mice. I don't know necessarily if that's a well-developed science, or how we understand the role of knockouts in specific genes. But so what? Okay.
Okay. Well, what I'm saying is,
first of all,
another thing, and another thing, like, I just want to comment what you said. ENCODE, they didn't look at the portions of the genome involved exclusively in development, right? So such DNA would only have function then. So I'm saying that all the evidence we see, the trajectory of discovery favors genome-wide functionality. We see limits. You're not going to get a dog as small as a mouse. We know there's animals as small as a mouse, like a mouse. We're seeing degradation. We're seeing variations based on pre-existing heterozygosity. I mean, this is all consistent with biblical creation. I have no reason to give up this model of biblical creation. Go ahead.
So, first of all, I kind of want to ask you to clarify what you mean by non-coding or non-functional. I think you said regions of DNA.
Well, it's like I asked, because I didn't want to straw man your position. So these non-protein coding regions, right? And I understand that there's some messenger RNA, functions that occur in there that even evolutionists will agree with. But what I'm saying is, we're seeing more roles that are playing in, gene expression, regulatory roles, placental, embryological roles. So this would actually help us understand that our genome is polyfunctional and polyconstrained. So any change in a genome that is genome-wide functional, it's going to be deleterious, and it's just going to degrade genomes, much like rust degrades a car.
Sure. I mean, except for earlier on, that contradicts what you've said, because you've already agreed to the point that the effect of the environment and the effect of certain mutations on populations can cause beneficial information.
Okay, so I don't want to just repeat a bunch of things. Okay, so we see dogs produce dogs. Let's make it simple for the audience. We see elephants
Okay,
produce
if you don't want to
elephants.
repeat a bunch of
Dogs and
things,
elephants are related through common ancestry, but we see no empirical evidence to suggest otherwise. We see limits. It's just a religion. I'm sorry. Like, I understand you believe in it, and I would put a capital B on believe. It's just
so I'll ask the same question that I asked before. What evolutionist has said that we would expect to see dogs smaller than the size of mice? Right?
Well,
I asked you that earlier. You didn't give me a answer to that question. I'm going to assume.
I think it's pretty obvious to anybody that if you're saying dogs and mice ultimately are related through common ancestry, I would say that the changes in living organisms must be limitless. Because if you're going to start with non-living chemicals evolving into a cell, and a single cell into a multi-celled organism, and a multi-celled organism into a fish, amphibian, reptile, mammal, bird, ape, human. I mean, there's a lot of new information involved in that. And even talking to CRISPR the other day, I mean, he had a lot of non-answers to those original questions about, say, your single-celled organism up into these stages. So I mean, I think it's pretty obvious that we see limits. It's a cute story, but it's just probably not true. Go ahead.
Well, sure, and that's generally why. Well, actually, no. I mean, we see transitional forms of organisms. We see organisms that are both aquatic
we see bones in the dirt. We don't see transitional fossils. We see fossils.
Sure,
it doesn't mean they're transitioning in any.
No, we literally do see transitional organisms that exist now. Look up something called a mud skipper.
Okay, are you familiar with the Dodge Journey or the Ford Flex? Tell me, are those SUVs or are those vans? Go ahead.
So I'm not going to answer that because we're.
Why not? Because you know that it's not.
That's a bad example.
So first of all, we're talking about evolution, which is an explanation of population dynamics, and secondly, we're talking about organisms. Last I checked, the SUV isn't an organism. So I'll ask you again: are you familiar with the example of a mud skipper?
I know what a mud skipper is, and mud skippers produce mud skippers. That doesn't mean that mud skippers, elephants, and pine trees are related through common ancestry. A Dodge Journey.
No, and that's not what I asked you either. Now, what I asked you,
in the biblical-based model,
I asked you,
what are the time, please?
Argument on me. Go ahead.
What I asked you, and what I told you actually, is that there are transitional forms that exist, and I gave you an example, for which you said
that's not transitioning.
For which you asked me to compare an SUV to some kind of other vehicle.
No, it's not an SUV. It's neither SUV nor van. It's a transitional fossil.
No, it isn't.
That Dodge Journey is related to a skateboard. Woo! There's your science right there.
I'm asking you again. Are you going to stick to
mud skippers? Dogs produce dogs. They're not related through common ancestry.
Because you say so, or because you're not willing to address the actual science?
I'm addressing the science.
No, you're not, because when I ask you, have you heard of a mud skipper? You raise the example of a truck.
Stay in school, everybody. Stay in school. Sorry, go ahead.
I'll ask you again. Have you seen a mud skipper?
I'm completely familiar with a mud skipper, and as far as I've seen and observed, mud skippers are producing mud skippers, and you can believe that a mud skipper and a dog and a pine tree and an elephant are all related through common ancestry. That's a belief system.
We were talking about transitional forms and how you said transitional forms.
What's that transition?
Exist within the fossil record.
All animal kinds today with species of every kind have so much variation. You know, some are bigger, some are smaller, bigger dogs, smaller dogs. It means that all animals today look like transitional forms. No, so all transitional forms used by evolutionists could only be variations of animal kinds we see today. Pre-existing heterozygosity and tens of millions of original DNA differences explains the evidence better than molecules to man evolution explains it. Go ahead.
So, once again, you're wrong. Because
you can say I'm wrong, and you can repeat your mantra. It doesn't make it true.
The same applies to you.
So, transitional forms, as predicted by evolution, predict mutations and also predict that certain characteristics, which we do observe, occur in a transition from one organism between another type of organism. A mud skipper is an example of this.
What's the mud skipper transitioning into?
So, a mud skipper is showing an example of an organism that is normally aquatic, a fish,
that can survive on land.
So if we look at mutational hotspots, right, nucleotides that are subject to mutations that are going to help them adapt to a certain environment, okay, this is design variation. So whether this mud skipper has been, designed with pre-existing heterozygosity, whatever the original created kind was, it has varied and it has adapted to its environment. And you know what? It might be a mosaic. If all penguins...
Of course. Did you pay attention to what I said? Do I need to repeat what I said before you decided to start talking again?
Yeah, go ahead. Repeat what you said.
So what I said, once again, is that transitional forms, as predicted by geneticists and also by the fossil record, are organisms that, given certain mutations, are in a transition from one type of organism, from one clade, for example, into another clade of organism. So yes, of course we see change in phenotypes, and of course we see change in information that's present in the genome because mutations are occurring, and that successful mutations that produce beneficial mutations are being selected for.
So what I'm saying is, based on the design model, we also predict a nested hierarchy. You don't like the example of modes of transportation, but based on design, so human design, and we're created in God's image, we're going to look at modes of transportation and conclude that, wow, that, would be a very good inference as to how God may have designed
God's a shitty programmer. Sorry, my bad.
If anything else, the intelligent design shows more how anything else is designed than humans or other organisms.
I'm saying,
a different conversation.
All I'm saying with my point, and you can, like it or lump it, and the audience can decide, is I'm just saying that the invention of crossover vehicles, I don't know if you know what those are, Google, Dodge Journey, Ford Flex, for example, the distinction between cars and SUVs is becoming blurred. And what is currently labeled a car and what is labeled an SUV is now a matter of debate. So human engineers have designed and are still designing transitional forms. That's why I say traits are inherited, bones are not. When we look at the genetic level, we're seeing a genome that has a trajectory of genome-wide functionality. We're seeing losses of information, genetic information limits. This is more consistent with a biblical-based model and design. Go ahead.
So do you understand the purpose of the fossil record as to how it pertains to evolution?
How does a fossil form to begin with, since you've said fossils so many times?
Sure, fossils tend to form by rapid burial, but they can form by other means as well.
Like what other means, for example?
I'm not about to go into the laundry list, but I'll just list the most common example, which once again is rapid burial.
Okay, so I would say that the vast majority of fossils were from the global flood. And hear me out. There is evidence that the Earth was once underwater. I mean, we see marine fossils on mountains and in landlocked areas far from the sea. We'll probably agree with that. Some sedimentary rock layers extend over entire continents or even further. And the thing is, the deposition of those layers had to have been catastrophic, or else there would not have been much fossilization. I mean, you just admitted that these fossils are formed through rapid burial. Let me ask you a question. How many animals do you believe died today? Just today?
Died today? I don't know. Probably somewhere in the hundreds of thousands. I don't know.
I would say even more like millions, but even hundreds of thousands. How many of those do you believe fossilized?
Probably not very many, considering the means by which most organisms actually die.
Exactly. So for somebody with that basic assumption that the Bible is true and a global flood must have happened, the evidence is overwhelming. I mean, there are fossils of animals giving birth. I mean, think about that. Fish being eaten, suggesting sudden and rapid burial. But here's the most important part if you want an observation, and then you can continue. Look at Mount St. Helens. What did that demonstrate? It demonstrated that sedimentary layers, hundreds of feet thick, could be laid down in hours to days. Canyons can be formed rapidly. It can explain how multiple fossilized forests, and I suggest looking this up, could form as the result of a single volcanic eruption. And possibly, and this is what I find cool, how coal seams could be produced quickly. There's so much evidence in accord with the flood of Noah that you admitting that fossils are formed through rapid burial, I mean, that only helps my case even more. Go ahead.
Sure. I mean, you can also make sense of it by observing the fact that volcanic eruptions, other seismic events like earthquakes and other things that I'm not thinking of at the moment, produce the same kinds of effects that also will cause organisms to undergo rapid burial, to have what we would call fossils. And
Well,
here's actually an experiment we can test for to see if the global flood is true, right? And so that experiment is with trees, dendrochronology. So the idea fundamentally is that the rings on a tree, fundamentally based upon that year or whatever particular way we do it, generally it's by the year that tree was in that environment, we can test whether or not, we can see rather, what the water levels are like. We can see, oh, was it a dry season? Was it a wet season? Was it salty? Was the water more basic? Was it more acidic? Things like that. So, interestingly enough, we've done experiments with trees. We've taken samples of tree rings, cut a tree open, look at the rings from all over the world, grant you. And we see that there are certain observations within the rings we can date and try and approximate how far exactly that these things happen. But what we don't find is a universal event where all trees share more or less the same particular trend for a particular season or for a particular time span. We don't see an instance of what you would call a global flood, because if it were, trees that exist and that have existed for some thousands of years would show these traits.
Well, see, the thing is, you're basing a lot of that on some assumptions that obviously a global flood hasn't happened and that rates have remained constant. As a matter of fact, some trees do produce multiple rings, but what I mean, and I understand what you're saying, but I just want to say one more thing, and then we will comment on that. Everything that I said prior to what you just said, I think is strong evidence for rapid burial based on a global flood. But even if we look at a genetic level, creationists and evolutionists, they do agree we were all descended from 3 women. Okay, so, and correct me if I'm wrong, I don't want to straw man you, but evolutionists believe these women were not the only ones alive at the time, right? But many more were around, and they definitely don't believe that these were the 3 daughter-in-laws of Noah. But creationists, we believe that these 3 women were indeed the daughters-in-law of Noah. So we actually
they were primates.
Well, we actually call this the LMN out of Africa scenario. But you see how that incredibly close this fact is with a literal interpretation of Genesis. I mean, we can track that back through mitochondrial DNA and actually see that evidence not only in, say, the fossil record, but even on a genetic level. And back to your tree rings, isn't, like, if we look at radioactive elements, okay, you would say that would prove probably that there was no global flood and that, the Earth is, billions of years old. But wouldn't that also be based on assumptions, right? Such as, no daughter element present in the rock.
Daughter element. What?
So let me provide an analogy, right? So let me provide an analogy to kind of explain this whole thing about your assumption, right? So let's assume that, for the sake of argument, I'm cooking a meal and that I want to somehow classify or quantify, rather, or map out, or whatever you want to say it, however you want to phrase it. But I want to map out particularly how when I heat the pan, how the distribution of heat goes through that pan over a specific period of time, right? And there's going to be some kind of model that dictates or that tries to govern how this behavior occurs. And, well, the interesting thing is, in the case of radioactive decay and daughter isotopes, I grant you, I'm not a nuclear physicist, but my understanding of it is that when you have, for instance, a radioactive element that that is gradually decaying, that is undergoing beta emission and releasing other kinds of particles that are, being let out over certain amounts of time, that it takes so long for a particle to release a daughter isotope, for a daughter isotope to actually be formed and present. And that, based on that assumption, even if there are, 1 or 2 daughter isotopes that are found, it's relatively insignificant because in practice you're dealing with isotope samples that are in the billions and jillions.
Okay, so let's break this down then. Okay, obviously for ourselves and the audience, because obviously we're both not, like you admitted, I'm not an expert on this either. But I seen Athena kind of blurt out daughter element as if he thought it was absurd. Like, let's look at a radioactive element. Okay, so let's break it down. You know,
No, hang
there's
on.
radioactive element-
It's just that I never heard of that term. You know what I mean? That's why I was
Okay.
like,
I believe
never
it's
heard
called
of it.
daughter isotope, but I'm not quite certain on that.
Okay. So let's say we got a radioactive element. Okay, we would call that a parent, which would, you know, transform or decay over time into a non-radioactive element called a daughter. That's all I meant. Whether it's a daughter isotope, but let's say, for example, uranium to lead. Okay, you know, this would happen with, you know, a characteristic rate, which we would obviously call a half-life. You know, obviously we're simplifying this, but that would technically be the length of time it would take the parent element to transform into an equal amount of the daughter element, right? So over time, the amount of a parent element in the rock, it decreases in the amount of the daughter isotope in the rock increases. So the point is, we're not measuring the ages, we're actually measuring the amount of isotopes present in the rock. So the age is not actually measured directly. So if the Earth is only a few thousand years old, even trace elements, like you were saying, just trace elements alone of the daughter element will increase and provide inaccurate answers of even, you know, up to billions of years old based on those initial assumptions. And the fact that we predict that because of the fountains of the great deep breaking open and the Earth cracked like an egg, right? Like an eggshell. The catastrophic consequences of that would be detrimental. And I feel like what we see, you know, in geology is perfectly described based on that. Would you agree with my assessment there of radioactive decay? Go ahead.
So fundamentally, radioactive decay is a measurement of when I have some concentration. Well, when I have some amount of an element, and it is decaying into a daughter isotope, which may be radioactive. I'm not sure if that occurs. It might, but for sake of simplicity, if it decays into a normal element, what is being measured is typically the decay rate or the half-life sometimes of that molecule. So what is measured experimentally and what seems to be consistent through measurements that we've made using theories in nuclear physics is that it takes a specific amount of time for some element, like uranium, for instance. Let's say it takes, I don't know, 2 million years for the massive uranium, you know, whatever the radioactive form of uranium is, to reach half of its initial mass. And that this can only occur over certain amounts of time. And so far, measurements have been consistent with that. So when we're seeing, for instance, like, oh, look, we only find, you know, such and such percent mass of an isotope. Well, we know that certain decay rates produce these atoms, and that it would take so long for these particular atoms to be released by this radioactive element. So the measurement of isotopes would tell us about how long it would take for this radioactive element to release these products.
Okay, so and I understand what you're saying, but in regards to our basic assumption, I mean, for one, contamination is common, okay? Secondly, since there are not actually conclusive starting dates, say for the radioactive decay, the age it's going to start with is really just, like I said before, an assumption or a guess. And most importantly, according to our model of catastrophic plate tectonics, that would increase decay rates. But a big thing would obviously be contamination. And
Sure. I mean, the thing is that
So, from my understanding of it, is that radioactive elements tend to only react with certain things to accelerate decay processes. The issue with that would be that, as far as I'm aware, as far as papers that people have told me about, is that radioactive isotopes tend to be in relatively isolated environments. They tend to be left to their own devices and irradiate. Fundamentally, though, the assumption you're raising issue with, obviously neither of us are nuclear physicists, so we can't pin down the assumptions of nuclear physics. But so far, I mean, nobody really rejects any assumptions that nuclear physics makes up to the point until we start judging the age of a fossil or something like that.
Okay, and according to catastrophic plate tectonics, you know, that rate would have increased by heating, and from much material, say from inside the Earth, that came out, because we do know that exposure to heat or cold can change rates. But the coolest thing about it is, in just a second, the coolest thing about catastrophic plate tectonics and the model we've derived is there are falsifiable predictions. For example, the pre-flood ocean. For example, the ocean crust. Okay, so based on the fountains of the great deep breaking open, much like I said before of an egg cracking, like a shell, it was dragged down into the mantle. Okay, this process is called subduction. Okay, the cold ocean crust then. Okay, here's the prediction. It should still be cold, obviously, if you're following, since this occurred only thousands of years ago, according to our model. I understand you don't believe the Earth is thousands of years old, but even though it has descended into the deep, hot mantle. Now, you can look at this as well. I can provide the website. It's based on a secular website, actually. Seismic data from NASA has actually revealed enormous slabs of cool rock under North America. Okay, so down in the core itself, which should be warm, okay, according to your evolutionary assumptions and theory, but confirmation actually of flood geology, which is quite cool. And we see the after effects of these plate tectonics. I mean, we see all the fault lines. Obviously, none of them are my fault, but we see the plates are moving. We see, I mean, such rapid evidence, and I think we've. How do you feel about that? Go ahead.
So the one thing that I have read is that, yes, that the decay rates of certain radioactive isotopes can change, except for it doesn't really make too much of a difference, because the rate at which they vary, for instance, so, you know, let's say uranium takes 200 million years in order to decay into lead, for instance.
Oh God, that's funny.
The rate at which the variation to which this can occur, based upon extreme heating or based upon exposure to some kind of high energy electromagnetic field, is at most plus or minus 20, plus or minus, 1,000 years, which isn't that horrible, because we're dealing with a time span of millions of years that an organism could have occurred in.
Yeah, I'd just like to interrupt something. Somebody asked me in the live chat, please do me a favor, ask the creationist dude if he's being paid by word or by paragraph to drag this stuff out. Inquiring minds want to know. Little humor there, just to settle us down,
Yeah, no, I think actually, how long have we? I think it's been a good discussion. We've talked about a variety of topics. How long have we gone for? I think we agreed to about an hour and a half.
Well, I don't think we ever agreed. Maybe we did, but I don't remember. But Crispr wanted to go in there for a bit, if you don't mind.
Yeah, I think Immutable Destiny and I have had a good informal discussion. I look forward to re-listening to. I'm going to upload it to my channel for sure. I'll probably break it up into pieces, and if Crispr wants to come in as well, I'm sure we can. I think we'll just continue more of, say, a hangout between a bunch of people. I think our discussion between Immutable Destiny and I has concluded, so that'll be like what I post, as I'll probably just title it Talking with Immutable Destiny. I had a lot of fun, and if you just want to read, this can be like the after show, right? Because these discussions can be a little exhausting. So I don't want to go into anything heated with CRISPR. Let's just have a nice after show, nice little conversation for a bit, and then I'll personally call it a night, and you guys can continue on amongst yourselves. And thanks for having me on, Athena. I'll come on as much as you want. I think it's fun, and I certainly enjoy it.
These discussions do get heated. Trust me. I know.
But at the end of the day, we all remain friends. So what's up, Chris? What's up, CRISPR? How you doing, brother?
I'm doing fairly well.
Good, man.
Yeah. See, I had a lot of notes here on the side. I'm not sure where to even start with it.
Well, first off, how do you feel the discussion went? Did you enjoy it? Did you feel like we brought up some topics? Did we cover a few things that, like, how do you feel it went?
I think it sounded a lot like the conversation you and I had. So I don't know really if there's anything else to say, but yeah, I don't know. Let's see. One of the things that I think you seem to miss about ERVs is that ERVs, viruses in general, necessarily must have a mechanism by which they can induce transcription, right? So wherever the ERV is, you're gonna get transcription. And
are you talking about spurious transcription? You're gonna get some type of function based, because remember we were talking about spurious transcription.
Yeah. Well, but what I'm
to the ERV.
So what I'm talking about is that the ERV, in order to produce the viral proteins, it's got to transcribe them, right? First, it uses reverse transcriptase to get its genetic material into the genome, right? And then it has to transcribe its genome back out so that it can be translated. So that means it has to have a bit in there that will induce transcription. Now, if you lose the viral genes, but you keep the promoter region, you just get transcription of whatever is left.
Okay, so where I'm coming from is I'm saying, and obviously I'll allow you to respond to this, but I'm just saying viruses, at least it's not observed, they do not randomly insert tens of thousands of, say, these endogenous retroviruses, which just happen to be in exactly the right location and having exactly the right sequence to perform some valuable functions. So I'm saying no ERV should have function, because the fact that there's increasing evidence that they have important functions in the placenta and in the embryo, and the fact that they aid transcription in a fifth of the genome, I would say this is strong evidence that ERVs were possibly not the product of retroviruses, or it could be a weakness in the system. But most importantly, and you're going to know about this because you're a scientist, there are cell processes designed to weed out harmful or viral infected genes known as apoptosis, right? So why, after millions of years, do we still have so many viral infected ERVs, ERV cells? Because shouldn't apoptosis have ridden them long ago? But apparently it hasn't done anything at all. Go ahead.
Well, that's not how apoptosis works. But anyway, so you previously defined functional as basically transcribed, right? But any ERV must cause transcription.
Transcription, but also very important placental roles. And
well, no, but you didn't define functional as being transcription plus do something. You defined it as just transcription.
Do these ERVs do something?
Some of them do, but that's not how you define functional. You define functional as just transcribed. If it's transcribed at all, according to you, according to what you've said multiple times, including more than once in this hangout, if it's transcribed at all, it's functional, according to you.
Transcribed suggests function. We haven't done these gene knockout tests.
Well, actually, it doesn't suggest function.
But you just said that these ERVs have placental functions, embryological functions. That's consistent with my model. You can have any type of of this all you want.
It's
consistent
not
with design.
consistent with your
It
model.
is consistent with design.
But so firstly, the fact that some ERVs have some functions which may or may not be necessary depending on context does not mean that all ERVs are functional, obviously. Additionally,
I think it's important for the audience first, because I believe we speak, and by speak I mean understand, maybe 1 to 5% of the DNA language. How much do you believe we understand or speak of the DNA language? Go ahead.
I still honestly don't know what you mean by the DNA language.
Okay, so for one, we've already overturned ERV from junk to functional. Okay, so I think that's consistent with us. Secondly, my question is, once again, I'm going to state, how much of our DNA, deoxyribonucleic acid, how much of our information systems do we truly understand? Like,
That was
another way to ask it.
That was a remarkable restatement of the thing I asked you. You just re-said the thing I asked you.
You don't understand such a simple question. If we perform these gene knockout tests on humans and other mammals,
because it's like
what type of functions they have, why are you so?
How much
we understand it all?
How much of the squanch language do you understand? What the hell are you talking about?
Exactly. If I look at a Russian,
I know what DNA is.
I'm not gonna understand any of it. But it doesn't mean that if I look at something that I think is junk or non-functional, I'm not gonna conclude, oh wow, that really is junk, or an evolutionary leftover, or an ancient repetitive element. I'm ignorant of the language, and I'm saying you're ignorant of the DNA language. That's all I'm saying.
Oh, so yeah, we can tell whether or not things are functional.
Oh yeah, have you done these gene knockout tests on humans and on other mammal species? And how much testing have they done?
Funnily enough, yes, I have. But there are other ways beyond knockout experiments to test for functionality, and knockout experiments aren't even really the best way to do it necessarily. So
I would disagree with that, but go ahead.
Well, I'm really impressed that you would disagree with it, but I don't know what your point is, because
okay, about the say embryonic or placental development, okay, I would say it's a mystery at this point. The fact we don't know the manufacturing tools of, say, embryonic development does strongly hint that we don't understand most of the DNA language. And the fact that we only speak 1 to 5% or understand 1 to 5% of the DNA language, and ENCODE has revealed that 80% is transcribed. And all I'm saying is that suggests functional. Okay, so that's our prediction.
So when you say that it's found that 80% is transcribed, you understand that all that means is that they got at least one read in one sample, right?
One read in one sample. Yeah, obviously I understand that, that this isn't. How much did ENCODE actually test?
Well, they tested a lot, but the question is, if you only find one read in one sample, when you would expect for something that's actually doing something that's being transcribed beyond a spurious level to find millions of reads across the samples. Do you think that one read in one sample is impressive?
I would say that doesn't definitively give us a function, but it does suggest possible functions. So I want to ask you, pseudogenes, are they part of this 80% of that section that ENCODE tested? Would pseudogenes be part of that was shown to have this spurious transcription or transcription?
I imagine they tested a lot of different things.
Okay.
It's been about 3 years since I read through their work in detail. So
okay, well, I'll give you the answer. Pseudogenes were definitely part of the 80%, and we know that some pseudogenes are actually no longer pseudo. That means that 80% function is beginning to look more and more reliable, as we are predicting. And the fact that we know so little about the embryological developmental phase is strong evidence.
The real problem
for
is
creation. Go ahead.
that we know that the absolute maximum amount of the genome that could be functional is 25%. At
you know that for a
absolute
fact?
most, yes.
So you speak 1 to 5% of the DNA language. You know nothing about the construction tools that are taking part in that developmental
we
phase.
actually do know a lot about development. I don't know where you're getting that we don't know anything about development. We know a lot about development.
But the thing is, a lot of this development, a lot of these construction tools being utilized during that phase are in that non-protein coding region that we, or evolutionists might say, are junk.
I can't imagine what your point could possibly be with that.
The whole point is the trajectory is pointing towards, I understand you disagree, it's pointing towards genome-wide functionality, but based on the fall, based on our model of degradation and genetic entropy, which I understand you don't agree with, that's fine. We will expect some junk, some broken genes, some pseudo genes, but not, say, as many as evolutionists would predict. So I feel the empirical evidence is more consistent with biblical creation. Go ahead.
Yeah, well, but the problem is that, again, there have been studies done, fairly substantial ones, that have demonstrated the amount of the genome that could possibly be functional, and this is on a very broad, both theoretical and experimental basis. So if you're wanting to say that it's, the majority of the genome is functional, you're already wrong. You just cannot be right about that because it's already been demonstrated to be false. Now, I know you're not up on the literature.
Oh no,
actually,
I'm up on
that was demonstrated like 40 years ago.
Evolution predicted junk since the 70s. Would you agree with that? Since the 70s, they have predicted junk. They didn't predict.
Yes, 1972.
Is they didn't predict that ENCODE would sequence and look at that the analysis there and conclude that 80% is transcripted. So now you have to use your rescue device based on that evolutionary bias and assumption and say, oh, well, it's spurious transcription. Oh, well, it's this, it's that. Common ancestry markers in DNA has a junk DNA assumption to work. And that's a fact. Without junk, you're genetically dead. And
are you under the impression that spurious transcription is a concept that came about after ENCODE?
No, I'm saying that they didn't predict that 80% of that would be transcripted. There's
actually the point of spurious transcription is that it predicts that the majority of the genome will be transcribed at a spurious level.
Are you familiar with Francis Collins, who's I think he headed either the Human Genome Project or, I mean, he's pretty
yes, I know who he is.
Okay, and this definitely isn't a quote mine, but even he said, and I think this was after his prominent work with Language of God, and a lot of evolutionists look to him actually for evidence and information, but he said in terms of junk DNA, we don't use that term anymore because I think it was pretty much a case of hubris to imagine that we could dispense with any part of the genome as if we knew enough to say it wasn't functional. Most of the genome that we used to think was there for spacer turns out to be doing stuff. So this stuff that, according to Francis Collins, that it's doing, is this stuff functional by your definition or functional by, say, the creationist interpretation of functional?
Yeah, so I'm not sure if you realize that you're quoting an ID proponent talking about junk
Francis
DNA.
Collins is not, he's not an ID proponent like Stephen Mayer, or he's all for universal common ancestry, Pons come to people evolution. I mean,
but
sure,
he is nonetheless an ID proponent. He doesn't support the same type of intelligent design, but he does still support a form of intelligent design.
Well, yeah, you know, God sparked the Big Bang and God sparked the initial life, but
and
those are just
controlled the development.
no, I think he just believes that God, you know, snapped his finger and, you know, the process began, but it was still all non-random.
So you heard, so you heard here, folks. God is Q from the Q continuum. Snap.
No,
Sorry, I had to make another joke.
I'm saying I would say theistic evolutionists, you know, holding on to microbes to man evolution. I think it's pretty obvious that, you know, they're compromising because, I mean, for one, why would God use that process of death? And secondly, it really is just God of the gaps. Hey, evolution happened, but God snapped his fingers and, you know, here's life, and God snapped his fingers and here's the Big Bang. I mean, that's we don't have to get into that conversation, but I'm not saying that I agree with Francis Collins' Athena or Midnight.
Yeah, I never said you were, but you know, but when you think about it, you know, the creation model also seems to think that God created the universe snapping his fingers.
Well, yeah, but our model is totally different. I mean, have you listened to anything I've said in
No, I just I've honestly been
pre-existing heterozygosity?
tuning you out, dude. No offense.
Oh, so that was another good one. So the heterozygosity, you realize that the absolute maximum number of variants for two people would be 4, right? You would have 4 variants.
I completely understand, you know, alleles and allele frequency, but I'm saying that starting with heterozygous organisms, visible distinctiveness in offspring, it would be apparent right away because recombination, gene conversion would provide many new varieties of those combinations.
No, that's not how that works.
Yeah, but you're assuming that those differences weren't already built in because you're looking at those.
You could have 4 differences built in. You could have 4 different alleles for every gene with 2 people. Each of them could have 2 different alleles. So you'd have a total of 4 alleles possible. That's it.
No, because a small heterozygous population will tend towards homozygosity. So when this happens, some recessive traits will be revealed. Look at the Mendel experiment on the P proteins. It shows that speciation and new traits can happen quick based on those recessive and dominant.
Yes, but the number of possible alleles is 4.
Nope.
Not infinite.
The amount of possible allelic variety based
Is
on those
4.
millions of differences in DNA sequences of
pairs, you can have
limitless.
Each of them can have 2 different alleles. They cannot have more than that. Only 2. Only 2. Between the 2 people, between the 2 people, you could have 4 alleles. That is the most.
No, you don't even understand what I'm saying. 4 alleles with pre-existing differences can, by estimate,
but each allele,
80,000 pre-existing differences. Don't cut me off. That can have 80,000 pre-existing differences. Okay, those tens of millions of nuclear DNA differences you see and assume are based on mutations. We're saying those were placed and encoded into the original created kinds. That plus pre-existing heterozygosity is more than enough variety and potential for speciation.
Okay, so you don't know what the word allele
means. Darwin. Your argument is debunked on the first page.
So
Get out of here.
You don't understand what allele means because an allele is the entire gene. It's a version of the gene. So if there's multiple differences in the gene, all of those differences make up one single allele. And each person can only have 2 variants.
But what I'm saying is, if you look at, say, Adam and Eve, okay, 2 people, low allele and low genetic diversity, that matches. You would look at the original created kinds, that would be high allele and high genetic diversity because you're looking at populations of heterozygotic organisms. Go ahead.
Okay. So what you're saying is...
So do you think that Dr. Nathaniel Jensen wrote an entire book, wrote all these predictions, but what you're saying just completely debunks it? I mean, you think he just completely overlooked that point? I mean, we're saying
I don't know.
Nathaniel Jensen actually, turns out,
as people have read his book, it turns out that he discarded information that was irrelevant, or not irrelevant, but was inconvenient rather to his own predictions, and that what scientists have already found.
No, because when he debated Dr. Mays, he exposed him for not understanding that we are saying that these tens of millions of nuclear DNA differences, probably 90% of them, 10% of them based on mutations, were designed variation. That combined,
Standing.
So actually, Jensen's comeback, whenever he was confronted with actual things that his book mentioned, was show me where it is in my book. Not show me the literature, but show me where it is in my book.
Because everything that Dr. Mays was bringing up was explained in his book through those tens of millions of nuclear DNA differences from the start.
Sandy, you're missing something critical here, right? Which is Noah only had 2 of each kind. 2.
Yes, but up to that point,
Be damned, they didn't make it past the flood.
The amount of compressed and hidden information and hidden traits.
Where was it hidden?
Limitless.
Where was it hidden in the genome?
Hidden in, well, for one, in a lot of these DNA sites that you would call junk or non-protein coding. But like I said before, 4 alleles with pre-existing differences can, by estimate, have 80,000 pre-existing differences. I don't understand.
No, it can be 4.
It can be hidden because if it has the mutation, if it has that particular variant, it would be constituted already by the definition of the allele. So that argument fails.
No, it doesn't fail. And actually, after the global flood and after Noah's Ark, based on those after effects of the flood, the radiation, that would have sparked tremendous variability, allelic variation based on, say, the radiation after the flood. It's really not an issue at all based on that pre-existing heterozygosity. But we can agree to disagree. That's fine.
We can move away from how wrong you are about genetics. That's fine. Let's talk about, you were saying, I believe I heard you say that it's your impression that the rate of radioactive decay must have been sped up. Did I understand that right?
So you want to jump into actually, yeah, we could talk about that, but I want to talk about because I think a strong evidence of molecules to man evolution, if you would agree, would be the chromosome 2 fusion. Would that be something worthwhile just to get?
Oh yeah, that'll be fun.
If we're gonna rehash the same thing that me and Immutable Destiny discussed, we can do that. But wouldn't it be fun to have a variety of topics here?
Yeah, sure. Let's do chromosome 2. That'll be funny.
Okay, so if we look at chromosome 2, obviously we would, humans may have had. For one, I want to ask, when did this fusion occur? I think would be a good question. Was this in the human line, or was this in the line prior, like through our common ancestor between chimps and humans? Go ahead.
It occurred after the divergence with chimpanzees. Divergence from chimpanzees. Okay,
so technically the argument would be if humans and chimps share a common ancestor, then we should observe a fusion event. Human chromosome 2 shows evidence of a fusion event. Therefore, humans and chimps share a common ancestor, right? More or less, because human chromosome 2, say near the middle, is it like remnants of centromeric DNA?
No, it's not remnants of centromeric DNA. It's there are head-to-head arrangements of degenerate telomere repeats.
Yeah, so like telomeric DNA is only found on the ends of DNA, but on chromosome 2, you find that DNA in the middle, right? And,
in a head-to-head arrangement.
And is it vestigial?
Vestigial? I mean, it is what it is. What?
Like, is any part of that fusion vestigial? Like, is there any function to it?
No.
Why have we found telomere sequences in the DNA that actually prevent this fusion?
Right. So telomeres, when they're functioning properly, would prevent fusions. That is true. However, when telomeres are not functioning properly, they tend to no longer exist anymore, which allows for fusions between non-homologous regions of the chromosomes, which is most readily achieved between reasonably homologous regions, which would occur within subtelomeres, where you would find degenerate repeat regions, which is exactly what we see in the middle of chromosome 2.
Okay, so before we get into anything more deep in regarding to that, based on how I explain the argument, right? Like if humans and chimps share a common ancestor, there should be a chromosome 2 fusion. There is, therefore, that's evidence, right? But wouldn't that be a logical fallacy known as affirming the consequent? Like if the grass is wet, then it must have rained, right? But the grass is wet, therefore it rained. But the thing is, the grass could be wet for a number of reasons. So what I'm saying is that the human chromosomal fusion argument, and obviously I want you to comment this, it really focuses on a fusion event that is specific to the human line and therefore provides a highly limited, I guess, form of evidence for human/ape ancestry. Because if it occurred in that human line, but you're using that as sufficient and demonstrable evidence for ape-human common ancestry, isn't that just affirming the consequence? Go ahead.
That's not what anybody's doing. The argument is that without a fusion, things look really weird. There is a fusion, therefore things don't look really weird. It doesn't mean that common ancestry is confirmed. It means that a possible roadblock to a strong support of common ancestry has been removed.
Okay,
right?
but
It does not exist as a piece of conclusive evidence, singular evidence that demonstrates the case. Instead, what it does is it removes a problem to this thing being the case.
Okay, but how could the gene span the fusion site? Like seeing one part of it from one side to another seems a little bit unrealistic and a little bit of a stretch. Go ahead.
I assume you're talking about DDX11L2?
Sure.
So you don't know?
Yeah, that's exactly what I'm talking about.
Okay,
Like
yeah, great.
how would you, because for one, the telomeres are functional. Wouldn't that indicate that the fusion is impossible, or did that function come about through the chromosomal 2 fusion? Like, how do you reconcile?
Now, when you say the telomeres, do you mean the fusion? Are you saying the fusion is functional?
The telomeres are functional, which would make the fusion unlikely based on that function that it possesses.
I think that most people would agree that telomere fusions are indeed unlikely, but they do happen.
Here, but
we've seen a lot of them.
Do we see those fusions take place in human populations today?
Yeah, there's a guy in China, and I think a family in Sweden.
Are those passed on to?
Yep. 9 generations.
But what I'm saying is, wouldn't only a junk telomere be able to create this fusion?
But probably no telomere at all. Like I said,
I'm saying the fact that only a junk telomere can create this fusion, doesn't that alone debunk the fusion? And if there even was a fusion, based on what you're providing for the evidence of the fusion, sounds like a logical fallacy called affirming the consequence. So it sounds like either way, fusion or no fusion.
No. So the thing is if you knock off the telomere from one chromosome, right?
Yep.
That end of the chromosome is going to want to fuse. Now, you can't stop fusion with one telomere, right? You need one on either end, right? They work, the ends work like bumpers. If you only have it on one side, you can still get a fusion. Now, the most likely place to get a fusion is when there's some degree of homology between the regions of the chromosomes. The thing is, every single chromosome at the ends, inside of the telomere, you have subtelomeric regions. And these regions have areas of very high levels of movement within the genome, but they also have generally degenerate telomeric arrays. And those arrays are largely homologous to one another, which means you have a very good site for non-homologous fusion, because it's semi-homologous at that point. Now, what all of that means is that what you would expect to see at the fusion site is a mixture of degenerate telomeric arrays, which is what you see, along with the genes, pseudogenes, and various other sequences commonly found by the subtelomeres, which is also what you see, including, of course, a version of DDX11, which are only found by the telomeres. That's the only place you find it in the genome is by telomeres, and also in the middle of chromosome 2.
Okay, so from my understanding, this degenerate part that you're talking about, it shows function. Secondly,
it doesn't.
You just talk for a while there. That fusion thing was conceived, right? The chromosomal 2 prediction sounds like decades ago biology to me, because that fusion was predicted and conceived during the junk DNA era. Without junk DNA, the fusion really just collapses on its own. And lastly, based on what I said earlier about evolutionists, and in regards to this, all they have done is really documented direct empirical evidence. Say if this chromosomal fusion did happen, either way, I don't think it's evidence, but it happened in the human line. So it doesn't tell you when it happened and what was happening when it happened. So it sounds like presuppositions play a huge role on the interpretations of the evidence. And it also sounds like all evidence becomes evidence for evolution. For example, if chimps and humans both had 48 chromosomes, oh wow, evidence for evolution. Okay, chimps have 48, humans have 46. How do we reconcile that? Must have been some type of chromosomal fusion. Bam, evidence for evolution. Everything is evidence for bacteria to biologists, evolution. Go ahead.
Well, if there hadn't been a fusion, that would have been a fairly strong case against common descent.
Well, I'm saying there's evidence that possibly there wasn't a fusion, and I'm saying that even if there was a fusion, it doesn't tell you when it happened, what happened, and how it happened. But the thing is, based on our limited understanding of the DNA language anyways, and I've said that many times, it's premature to make these conclusions. And let's just say hypothetically there was a chromosomal 2 fusion. That means when it happened, it had to have been passed on to everybody for us to all have it, correct? I mean, is that not unlikely? And if it is likely, wouldn't that be based on a story? Like, aren't you going to have to tell me a fancy story on how that happened? Go ahead.
Can I do a screen share?
Yeah, go ahead. Screen share, and I'll present to you.
Okay, here I'm going to let you.
I'm going
to let you have the last words in regards to that. I'm going to have to head out actually in about a minute. Have the last words. I don't mind that, and you guys can continue the talk. And then we'll go from there, and we can do another one.
Hang on one sec. Before you leave, hold on. Present to everyone. There you go.
Okay, you want to see the evidence? This is the evidence.
I'll give you the last words, the last evidence. Go ahead. This
is a Centenary map. On the
interesting.
In the middle, you have human
Athena's like interesting, even though he's got no idea what it is.
I'm explaining it. in the middle, you have the human positions. On the left, you have the equivalent positions in mouse. On the right, you have the equivalent positions in chimpanzee, color-coded by the chromosome correspondence. This right here is the only jump.
Is
between
that
human and chimpanzee?
Does that
you have-
degeneration show any function at all?
These actually represent, each of these lines represents a fairly large chunk of DNA. Now, you look at this in mouse, there is no reason to not, if there's no common ancestry, to not expect to see something just as jumbled between humans and chimpanzees as you do as between humans and mice.
So
But you
I'm
don't.
saying,
You
saying
see
it
it
could
perfect
it could be evidence
symphony.
of degeneration. It could be evidence of. It sounds like there is some evidence that it's not, and I'm saying that if it is, you still haven't really given us any direct evidence for ape to human ancestry, because for one, it's going to have to be passed on to everybody, and secondly, if hypothetically this chromosomal fusion did happen, it could have easily happened immediately post-flood for everybody to get it, or prior to the flood, where the people coming off the ark could then pass it on. So either way, it's affirming the consequence, because there could be multiple explanations. Guys, have a fun.
Well, hold on. Before you go, I just want to, mention, something like, before you said Athena's like interesting, he doesn't know what it is. Well, here's the thing. I said interesting because I'm curious. I have a curious mind. That is all.
That's good. I like your open-mindedness, Athena. Athena, thanks for having me on Immutable Destiny. Good conversation, brother. Do it again. Tiger Man, not sure who you are, but we had fun as well.
Yes, I am not jungle jargon. If that's here. No, thank you. I don't associate me with that guy.
Yeah, you need to change your icon. If people can